Hello, I'm Peter Mortimer from the Institute for Autonomous Systems Technology, and welcome to the presentation on our paper on a fine-grained dataset and its efficient semantic segmentation for unstructured driving scenarios. This paper was made in collaboration with my colleague Kai Metzger. Our institute focuses on developing methods for autonomous navigation in unknown and unstructured outdoor environments. This often requires a higher level of robustness, as many assumptions made while driving in urban scenarios, like visible lane markings and wide roads, do not hold when navigating through a forest or along a field. We were especially interested in being able to visually distinguish between the different road surface types found on outdoor trails and whether the vegetation we encountered along the way poses an obstacle or can be driven over. To leverage recent advances in neural networks that can segment images based on their semantic content, we decided to create our own dataset with over 500 fully annotated images. We named our dataset TUS500 and are releasing it to the public as part of this publication. The TUS500 dataset consists of images taken on trails and forests around Munich. Our annotation policy is closely related to other driving datasets like Cityscapes or Kitty, but we lay our focus on a fine-grained annotation of the road surface and the surrounding vegetation. The scenes vary in the visual content. The dataset includes wider roads out of asphalt where we drive as part of a convoy, as well as scenes that contain barely visible dirt roads. As this bar chart shows, compared to other datasets, we distinguish among the observed vegetation on a more fine-grained level. We have a total of 7 different classes in the vegetation category and another 4 classes in the terrain category to segment the type of road surface on a more fine-grained level. The other categories are closely related to semantic classes found in other urban driving datasets. This should allow users to fuse datasets for training or to use our dataset to evaluate their algorithm's performance on different scenes. The high level of detail in our vegetation category allows us to construct experiments not possible with other driving datasets. For instance, we can evaluate how well a network can perform when we subdivide a vegetation category into smaller, more fine-grained categories. Here we can compare using just one class to represent any type of vegetation and one class to represent a road surface, to subdividing the road into 3 possible surface materials. We then separate the vegetation based on its drivability. Then we separate the drivable vegetation based on the height of the grass. And then the non-drivable vegetation is then split into bushes, forested parts, and scenery vegetation. Our first experiments have shown that the scene segmentation performance deteriorates at some point when the granularity has become too fine. This is clearest for classes that are visually very similar, such as low and high grass or bushes and tree crowns. Here are some qualitative results of the fast SDNN network on our test dataset. This network was trained on the 17-class distribution where the vegetation is separated based on its drivability. Thank you for your attention. We're looking forward to some interesting discussions at our poster booth. The TUS500 dataset and its pre-trained models are available online at www.moocar3.de/ICPR2020-TUS500.